Hello everyone. Today we are going to discuss the problem palindromic path queries in a tree. This problem was recently asked in the Leetcode biweekly contest. It was the last problem of the contest and is fairly advanced. So let's go through this problem. We have been given an undirected tree with n nodes and n minus 1 edges, a pretty standard thing. And we have also been given a string s of length n. It consists of lowercase English letters and the s of I represents character assigned to the node I. So the value s of I is assigned to the node I. You are also given a string array queries where queries of I is either a update query or like just a query between two nodes. So update means I have to change the character at any particular node to character C, and query UIVI which says determine whether the string formed by the characters on unique path from UI to VI can be rearranged into a palindrome. Okay, so what does this mean? Let's go to a tree first and let's check this tree. So if I select any two nodes, let me just, yeah. So if I select any two nodes, let's say I select node number 3 and node number 5. So if I go through the path from node 3 to 5, you can see there exists only one single path. And that is a property of the tree, right? There exists only one single path between any two nodes. So here the path would be something like this. Now, if I collect all the characters on this path, which would be C, B, A, B, C, and if I rearrange them, then whether it can form a palindrome or not, that is our question. In this particular case, it already forms a palindrome, right? C, B, A, B, C. It already forms a palindrome. But if the order was different, something like if the places were swapped and here it was like, let's say, C was over here and B was over here, then still the answer would be yes. Because if I rearranged B and C, then the answer would still be true. So we don't have to check for the exact palindrome. We have to check whether if I rearrange the characters on that path, then can it form a palindrome? So that's our question. Now, if you have understood the question, then we can proceed to the next part. So we have to return a Boolean array. So there would be various queries. For each query, we have to return true or false. So we can return it in an answer of size query, like what number of queries. So how to approach this problem? Let's talk about the prerequisites. So this is a fairly advanced problem and some advanced concepts are needed. You would need to know how to calculate the lowest common ancestor of a tree. You would also need knowledge about Euler tool, some basic bit manipulation, and you would need to know about range queries. Here we will be using penweek. Actually, this problem has multiple solutions. We'll be focusing on the point update and range query solution. There is also a range update and point query solution, but we won't be diving deeper into that. We'll focus on point update and range query solution. So let's first try solving a simpler problem. Instead of a tree, let's try to solve it for a static array first. Then we will go for dynamic array and then we will go for a tree. So let's say this is a static array. For the whole array, if I have to check whether like if I can rearrange some elements of the array, then whether it still forms a palindrome or not. To check that, I will have to check for two particular conditions, right? The first would be like if the palindrome is of even length, then the frequency of each character should be multiple of 2. Like each character should be 2 or like occur 4 times, 6 times, 2 times, 8 times. It should be multiple of 2 if the palindrome is of even length. And if the palindrome is of odd length, let's suppose I add one character over here. Let's say I add Z, then this also forms a palindrome. But here we notice that there is a character Z whose frequency is 1, which is odd. Not necessarily it should only be 1. It can be something like if I add extra C, there can be 3 Cs. But there is only one character with odd frequency and rest all characters with even frequency. So this is the first observation which we are going to need to solve this particular problem. So we will have to perform two checks. Like if frequency of all characters in the subarray, like in the substring, is even, or then yeah, we can rearrange it into a palindrome. Or if frequency is even for all characters except for one, then also we can rearrange it into a palindrome. So we have to check for these two conditions. So how we can check that? First, if we try to actually iterate and keep a count of each strings using some ordered map or frequency array or something, it would be O of n square. So instead of iterating upon whole substring again and again, what we can do is for a substring, like we can pre-calculate a prefix array. The prefix array would be of length n and it will contain 26 folders. Like it would be something like this. Let's assume we have only six characters right now: A, B, C, D, E, F, and this is our string A, E, F, C, D. This is our string, right? This one. So we can create a frequency array. At position 1, we have character 1 present. At position 2, we have character E present. So I'll mark it as 1. At position 3, we have character F present. So I'll mark it at 1. Then C, then D. And next, I will perform a prefix sum. So one would propagate forward. Here also one would propagate forward. The one from the E as well. Then here as well. And here as well. Here, 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 and here. So we have this prefix, some kind of setup. Now, using this, we can easily calculate number of like frequency of each character for any substring. Let's say we have to calculate for the substring 2, 3, and 4. So what would that be? It would be prefix of 4 minus prefix of 1, right? So I would just place it over here. Prefix of 4 minus prefix of 1. I would extend this and we can see it says C has a frequency of 1, E has a frequency and 1, and F has a frequency of 1. And that is true. So using this kind of setup, we can easily calculate number of like frequency of each character in that particular substring. In O of 26, because you only need to iterate upon each character once, and there are 26 characters. So in O of 26, we can actually get the frequency count, and we can actually check whether the frequency of all characters is multiple of 2 or not. So these conditions can be easily satisfied in O of 26. But this was for an array, right? And that was for a static array, not a dynamic array. What if I introduce a point update, something like go and change this character from D to E? Then what? Then in this particular setup also, I will have to change the frequency of, like I would have to change, let's say AEFCD, and I have to change E to again F. Then I would have to erase E, like earlier E was 1, then I will have to keep it as 0. The changes should also propagate forward, and then I will have to increase the frequency of F by 1. Now I will have to recalculate this prefix array thing from this particular index again, which would be O of n again. So it's not effective. So here we will use a data structure, which is Fenwick tree. Fenwick tree helps us avoid this, like we will not have to build the prefix sums again and again. We can perform point queries in O of log n, and we will still get prefix sums in O of log n. So that's an advantage of Fenwick tree over here. So we'll be using Fenway tree to perform point update to get the like to update the frequency of character, and we'll have the range query, like prefix query thing, to get the frequencies of character in a prefix of a thing. So prefix of R, and then we'll get prefix of L minus 1, and if I subtract both of those, then I will get the frequency of characters in that particular range. So for a dynamic array, we will need a Fenwick tree, and we will just have a prefix kind of setup to store the frequency of characters. Now we have solved this question for a dynamic array. But can we improve this O of 26? Like we are iterating upon each character, right? There are 26 characters, and would be 5 into 10 to the power 4 queries, and the each query would take log n. And again, if we are adding a factor of 26, then it might land somewhere in the TLE zone. So there is a way with which we can update this thing. Like instead of O of 26, we can perform a O of 1 check. So how is it possible? We are not storing the frequency of each character. Then how will we perform these two checks? Because earlier we said we are checking for the frequency of characters in that range. And if we don't contain the frequency, then how will we even check for those? So the solution is XOR. So let's figure out how. To perform this check, if frequency of all characters is multiple of 2, we don't need to store the actual frequency, right? We just need to know whether the frequency is odd or even in that particular range. Similar for this one, we can just store whether the frequency of A was odd or even, B was odd or even, C was odd or even, and so on. And if we got to know there is more than one character with odd frequencies, then the solution is not possible. So this can be easily done via XOR, right? Let me show how. Uh, let's come over here. Let's say we have the string E, D, C, B, A. I've written A, B, C, D, E in reverse. And A corresponds to 0 bit, B corresponds to first, C to second, D to third, and so on. So initially everything would be 0. Initially everything was 0. Now let's go through a string. Let's consider this string A, F, F, C, D. Okay. So our string is A, F, F, C, and D. So let's go to the first character, A. I will increase its frequency by 1. Then I go to the next character, F. Actually, I will have to add F over here. I will increase its frequency to 1. Then again F. I will increase its frequency to 2. Then C. Then I will increase its frequency to 1. Then again D. Increase its frequency to 1. Now this says A has frequency 1, C1, D1, and F1 for the whole prefix. But what if instead of storing actual frequency count, we only store their parities? So if it was 0, it will go to 1, and if it was 1, it will go to 0, like this. Now we don't need an integer to store the parity, right? We can just use 1 bit for each character, and there are 26 characters, so we would need 26 bits. So that means in one integer, we can easily store, in one integer, we can easily store the parities of a character. So let's say I have F, its parity is 0, E, parity 0, D, parity 1. See, there are three characters with odd parities over here. So using this XOR kind of setup, like instead of performing prefix of R minus prefix of L minus 1, like subtracting the frequencies, we can actually just take their XOR and use their parities to identify this condition. This condition, if frequency is 1 for at max 1 character. So we can use the XOR, and instead of storing a 26 size array at each point, we can do is store just a single integer at each point. So everything would get condensed into a single integer. And how can we get the range? Like how can we here we got the XOR for the whole prefix. This was XOR for the prefix, right? But what if I want XOR for a particular range? Then we can just apply the same principle as addition. For addition, we know prefix of R equal to prefix of like 0 to L minus 1, then continue from L to R. So since addition is distributive and XOR is also distributive, we can just replace it with XOR. Now, if we want to find XOR of a range, let's say L to R, then we can just perform XOR of 0 to L minus 1 on both the sides to L minus 1. And since prefix of a number with itself will result into 0, so this would completely disappear. So prefix of L to R would be prefix of R XORed with prefix of 0 to L minus 1. So we have gotten ourselves a pretty neat solution. Instead of 26 size array, a single integer can tell us whether there exists a character with odd frequency in a given range. Now we will use this particular trick in our solution to optimize our solution. So far, we have solved the problem for a dynamic tree, dynamic array in a very optimized way. But our question stated that we have to solve this for a tree, right? So let's look at the tree. We have already solved this problem for the array right now. Don't worry about the code for now. Just try to understand the logic. You can like see a chain of a root node to leaf node. Isn't it something like an array itself, 0, 1, 3, 7? That is, we can treat that like an array, 0, 1, 4 like an array, something kind of that. If we were able to find the XOR of this chain, if any one chain, then it might have been possible. So let's try to do that. We will try to flatten this tree into an array because we already have solved this problem for an array. If we are able to flatten this tree into an array, then we are nearly there. Like we'll have figured out 90% of this problem. And to flatten this array, we can use Euler tool. So I assume that you have basic understanding of Euler tool. If not, maybe you should look up some videos on YouTube and understand how Euler tool works. So I have written down the Euler tool for this particular graph over here. For Euler to just will explain just like when you go into a node, you store its in time, and when you explore its whole subtree and come back, then you log its out time. Uh, and so you get like for in time and out time, you get the moments at which you entered the subtree and exited the subtree. So if you want to perform some range operation in the subtree, you can just do a plus one at the entry time and a minus one at the exit time, like similar to partial sums. And you will have performed a range update in a tree. So we will be using a similar setup. So here is the Euler tool for this array. First we dive into 0, then we go to 1, then go to 3, then 7, then we are exiting 7, so we have written 7 dash, then we are exiting 3, 3 dash, then entering to 4, then exiting 4, then exiting 1, and so on. This is our whole Euler tool setup for this tree. Now, let's say I want to find any path aggregate for node 0 to 7, which is like A to D. So, which is 0 to 7. Oh, sorry. This is 0 to 7. Actually, this is quite simple. Let's take another node. Like we will try to find for 0 to 5. So this is 0 to 5. We are trying to find some path aggregates for 0, 2, and 5. We have to find path aggregates. So contribution of 0, contribution of node 2, and contribution of node 5 should be added. But contribution of all of these nodes should not be added, and not of this node as well. So we can see if we perform a plus something at 7 and minus something at 7 dash, similarly for 4 and 4 dash, 3 and 3 dash, 1 and 1 dash, then won't these things cancel each other out? So what would be left effectively? Let's see. We can see that 3 3 dash, 7 7 dash, 4. Effectively we can see this whole segment is being cancelled out. So what is left? The contribution from 0, this particular thing, the contribution from 2, and the contribution from 5. What if we perform a prefix sum on this whole thing? Like earlier, we just incremented the values at in time and out time, in time and out time. And then in the end, we perform a prefix sum over the partial sums array and we get that values, the net aggregate, right? So we will get the net aggregate of 0, 2, and 5. You can do this for any node. Let's say 0, 2, and 6. When you go to 6, 5 dash has cancelled out 5. 2 has been cancelled. No, 2 will not get cancelled because 2 is in the path, right? So you can see the paths which were irrelevant or unnecessary, they all have been cancelled out. So the only things left is what we required. So if I want to get some path aggregate for node 5, I will query till in time of node 5 and we will get the path aggregate. So using this property of the Euler tool, we will create a array and we will store the XOR. Like how we discussed, we will be storing XORs. You can also store the frequency maps on the each node of Fenwick tree, but for just the optimization, we will store the XORs of each character on each node of Fenwick tree. And whenever we have to query, let's query for 5, then we will go and check. Okay, the what would be the query Let's say what would the query A, B, and C return? It would return something like uh, the last character would be 1, 1, 1. This 1 corresponds to the frequency of A, which is odd. This one corresponds to frequency of B, which is odd, and this one's to C. What if I try to get the path aggregate for C, B, A, B, C? It would be something like C has occurred twice, so it would be 0. B has occurred twice, so it would be 0, and 1 has occurred A has occurred once, so it would be 1. So it would be the path XOR would be something like this. This would be the effective thing which would be getting out of the Fenwick tree. But Fenwick tree only helps us support root to any random node in the tree. It does not help get us the path aggregates. So for that particular thing, let's say I want the path aggregate for this thing. What I can do is calculate the path aggregate from root to 7, root to 4, and XOR both of them. Then the contribution of this particular thing would get removed because XOR with itself will remove the contribution. Then we will just add the contribution, just the LCA, and we have the path XOR. And for the path XOR, we will just check, okay, are all the bits 0? If yes, then it can be rearranged into a palindrome, or only one bit is set. Like if it is 0, 0, 1, or if it is something like 1, 0, 0, then it can be turned into a palindrome. But if it 1, 0, 1, it's not possible. There are two characters with odd frequencies. So that's what we have to do. So I guess the logic is clear up to this part, and we will move on to the code. So this is our solution class. Let's first go to the main function. First, we will have to, like, we have been given the edge list. So we'll create our own adjacency list. Then we need a up table to find the lowest common ancestor. We'll need in time and out time for the Euler tool. And this bits vector is for the Fenwick tree. And we have timer initialized with 0. So whenever we go for DFS here, so when we go into the DFS, when entering a node, we set the in time as U, and when exiting a node, we set the out time. And here we are calculating the 2 to the power ith parents of the current node using binary lifting. And here we are just continuing our DFS function. So this DFS function has a time complexity of n log n because linear is time complexity of DFS. And in for each node in the DFS, we are also calculating all of its parents. So it is log n. Here I have written 20 because phi 4 is generally log phi 4 to the base 2 is less than 20. So this is n log n. So this DFS will give us the up table, which are the ancestors, the in time, and the out time for all the nodes. Once we have those, we can continue with, like, we have with our update queries and the normal queries, whether the nodes, the path between two nodes contains a rearrangeable palindrome or not. So first, let's look into the update query. We extract the node at which we have to perform the update. We extract the character. Then we check what was the old character in the string, and we check the new character in the string. So let's say my old character, initially my setup was something like this. It was 0, 0, 0, 0 corresponding to, maybe I should not do it over here. I will do it over here. So initially my string was 0, 0, 0, 0, and actually it was, let's say, 1 because I had only A. Now if I change A to something like C, then I will have to make two changes. First, I will have to erase the contribution of A, and then I will have to add the contribution of C. So these are the two updates which I need to make when I am updating the character. So how we are doing that? We are just calculating the difference. Okay, what is the old value? I'll get the corresponding bit for the old value, old character. What will be the corresponding bit for the new character? And I will perform the net update operation in a single loop. Like instead of performing the operation twice, as you see, I have to remove the old one, then add the new one. I will merge both of those into a single thing. I will create a mask something like 1 and 1. So if I XOR these two numbers, I would get the answer as this. Yeah, so isn't it effective? Instead of performing two updates, first remove this one, then add this one. So instead of two masking operations, I can just create a single mask and I will get the result this. So that is what I am doing over here. I have, instead of performing two mask updates individually, I will create a single mask and I will perform the update. Now I have to perform the update at L and like increment the update at L and decrement it at R plus 1. Here I'm incrementing it at in time, which is L, but I am again, it looks like I am again incrementing it at out time, right? No, because XOR operation is invertible. What does it mean? What does invertible means? So it means if initially XOR was 4 and then again I perform a XOR of 4, then it would effectively result into 0. So I don't need, in addition we do plus 4 and minus 4, but in XOR to remove contribution, we just perform XOR with the same number again. So that's why here it's not minus diff, it's just perform XOR again with that diff value at out time. So this is our update operation. I'm also updating the character in that string. And then we have our query operation. I will extract the two nodes u and v. I will find the LCA of u and v, the standard LCA code over here. And once I have got the LCA, as I told, we will find the, okay, let me just erase this. Yeah, so to find the path 7 to 4, we will find 0 to 7. As you can see, u val, let's say u was 7, then I will query for in time of u, which will give me the XOR value from 0 to 7. Then again, I will query for v val, which is 4. So 0 to 4, I got the value from 0 to 4 using this query. Then LCA val. What is LCA val? It is 1. This one over here. Because if I take these two values 0 to 7 and 0 to 4, 0 and 1 are common in both of those and the contribution of both of those will get erased. So I will have to add the contribution of LCA once again. So here I will also add the contribution of LCA val again. So I will calculate all of these three values and combine them using XOR. Now we have the XOR of the path. Once we have XOR of the path, we will perform that check. What was the check? The check was check if number contains only one set bit. And how we can do that? Like at max one set bit. So if there is no set bit, that also works. And this condition, we just perform AND operation with number and number minus 1. And if it results into 0, then that means only one bit was set. This is a basic bit manipulation trick. You might be knowing it. And if any of these conditions satisfies, then that means the characters can be rearranged into a palindrome. And if it doesn't satisfies, then the characters cannot be rearranged into a palindrome. So this was the full logic for this particular problem. You should go through the code once. I hope uh, you have understood the logic for this particular problem because the setup was quite heavy. It needed trees, LCA, range queries, bit manipulation, and whatnot. Maybe you can try coding it without bit manipulation. Just store the frequency of nodes. It would be a little rough on the time complexity, but it would still work. And once you have created the solution based on frequencies, then we can try optimizing it for using this XOR trick. So both of these works, you can try with any of those. If you have any questions, you can leave it in the comment box and I will surely reply to those. So that was all for this particular problem. Thank you.